Welcome to this explainer. Today, we're going to completely defamiliarize the single most ubiquitous substance in your daily life. I mean, it's something you drink, you bathe in, and well, you're mostly made of it. But here's the thing, when you actually look at the hard data, it is arguably the absolute strangest substance in the known universe. Okay, let's dive right in by asking a deceptively simple question, just to kind of challenge what you think you know. What is the most dangerous, bizarre molecule on Earth? Seriously, think about it for a second. We're talking about a chemical that is literally fatal if inhaled. It can cause severe burns in its gaseous state, and it aggressively accelerates the corrosion of metals. Any guesses? Well, if you guessed dihydrogen monoxide, you'd be absolutely right. But you'd also be the victim of a classic scientific prank, because this terrifying sounding chemical is, well, it's just H2O, good old water. You see, this parody name brilliantly highlights how easily we just take water's extreme physical properties for granted, simply because it's absolutely everywhere. We barely even notice it. Section 1. The weirdest molecule. Defying standard physics? So the real secret to water's weirdness basically comes down to a highly specific number, 104.5 degrees. That is the exact angle between the two hydrogen atoms and the one oxygen atom in a single water molecule. And because of this bent, kind of V-like shape, and the fact that oxygen pulls electrons way harder than hydrogen does, the molecule ends up having a positive end and a negative end. This creates what we call a unique electrical dipole moment, making water a highly polar molecule. And that polarity is absolutely crucial. It allows water to form these incredibly strong hydrogen bonds with its neighboring molecules, which honestly is the secret behind almost everything water does. Just think for a second about how liquids normally behave. Usually, as a substance cools down, its molecules slow down, right? They pack tighter and tighter together, meaning the substance contracts and actually gets denser as it freezes into a solid. But water, incredibly, water does the exact opposite. No way, right? As water freezes, those hydrogen bonds we just talked about lock the molecules into this rigid, open hexagonal crystal structure. Because of this, ice actually expands by about 9%, making it distinctly less dense than liquid water. And that right there is exactly why ice floats. Think about the implications here. If water behaved like a normal liquid, our lakes and oceans would literally freeze solid from the bottom up. The ice would sink, expose more water to the freezing air, and eventually the Earth's oceans would just be solid blocks of ice. It would wipe out all marine life. But instead, floating ice acts like this giant insulating blanket, protecting all the liquid water and the life down below. It's a real game changer. Section 2. Earth's engine, geology and metabolism. Water is just incredibly resilient. Let's go back about 4.5 billion years. A massive impact formed our moon and very likely vaporized the Earth's early crust, essentially turning any water into this scalding, apocalyptic rock vapor atmosphere. Yet, we have mineralogical evidence from these ancient crystals called zircons showing that liquid water was back just 100 million years later. And by 3.8 billion years ago, we actually have physical evidence of pillow basalts. Those are specific rocks that only form during underwater volcanic eruptions. So water didn't just survive the absolute hellscape of early Earth, it fundamentally shaped the planet's entire surface. And it's not just planetary geology we're talking about, it's us. Water acts as the fundamental engine for all biological metabolism. In a process called anabolism, water molecules are literally removed from smaller building blocks through enzymatic reactions. This links them together to grow larger molecules, like the proteins right there in your muscles. On the flip side, in a process called catabolism, water is used almost like a microscopic axe to break chemical bonds, which releases the energy you need to live. Without water, these absolutely basic chemical reactions of life, they simply could not exist. Section 3. Human civilization. Harnessing the engine. The sheer scale of our modern dependency is pretty staggering. When we think of water use, we usually think in terms of drinking or maybe taking a shower. But actually, a massive 70% of the fresh water used globally is pumped directly into agriculture. We're using it to feed a rapidly growing population. And honestly, the math required to sustain this is pretty eye-opening. Let that number sink in for just a second. 15,000 liters. That is the global average amount of water required to produce just 1 single kilogram of beef. I mean, that's wild. That figure accounts for the water the animal actually drinks, sure, but way more importantly, it accounts for the massive amounts of water required to grow the feed that the animal consumes over its entire lifetime. And it's not just our food either. To produce 1 kilogram of cotton, which is roughly what it takes to make a single pair of blue jeans, requires 10.9 cubic meters of water. This level of agricultural diversion has profound, literally world-altering consequences. In fact, it was exactly this kind of immense water diversion for cotton crops by the former Soviet Union that drained the Aral Sea. It completely turned what used to be one of the world's largest inland bodies of water into a barren, toxic desert. Section 4. Across the universe, a cosmic byproduct. Now, to really understand the staggering scale of the cosmos, consider this. Back in 2011, scientists discovered a massive cloud of water vapor surrounding a quasar located 12 billion light-years from Earth. Get this, it contains 140 trillion times more water than all of Earth's oceans combined. 140 trillion. And because we're essentially looking at 12 billion years into the past, this proves that water has been prevalent in the universe for nearly its entire existence. It is quite literally a natural cosmic byproduct of star formation. But even much closer to home, water completely saturates our very own solar system. While Earth obviously has the abundant liquid surface water, we actually find trace water vapor almost everywhere we look. Venus's atmosphere has 0.002%, Mars sits at 0.03%. But then consider Saturn's moon Enceladus. Its atmosphere is an absolutely astonishing 91% water vapor. It seems like wherever we look out there, from comets to exoplanets, this molecule is just waiting. On that moon Enceladus I just mentioned, scientists actually believe there's a 10-kilometer thick subsurface liquid ocean hidden beneath its icy crust. Jupiter's moon Europa? It also hides a massive subsurface ocean. And Mars has vast amounts of water ice trapped under its soil and locked right at its poles. Water is this incredibly abundant cosmic ingredient just sitting there, waiting for the right planetary conditions to spark life. Section 5. The Global Water Crisis. The Water Bankruptcy Era. Coming back down to Earth, we're currently on a pretty stark trajectory. More than 50% of our large lakes have been steadily declining since the 1990s. 35% of our wetlands have simply disappeared since 1970. Today, a staggering 4 billion people experience severe water scarcity for at least 1 month out of the year, and droughts are currently costing the global economy over $307 billion annually. These compounding factors actually led the United Nations in 2026 to declare that humanity has officially entered the era of water bankruptcy. Basically, we're extracting far, far more than the natural water cycle can possibly recharge. So I'll leave you with this final thought to chew on as we wrap up this explainer. What is the true cost of our most free resource? I mean, think about what we've covered. Water is this alien, bizarre molecule forged in the turbulent birth of stars. It's a substance that literally defies standard physics by expanding when it freezes, and it is the fundamental biological engine responsible for the fact that you are alive right now. Heck, it makes up about 60% of your very own body. So the next time you turn on the tap, just take a second to remember exactly what it is that's flowing out. Keep learning, and I'll see you in the next explainer.